Great. So, hi everyone. My name is Enrique Sanchez. I am originally from Iberia, that's Portugal and Spain, but I have moved to Sweden since 10 years ago. And I have worked for over 10 years with aquaculture and human wastewater and organic solid waste reuse for practical experimental hydroponic cultivation applications. I've executed projects at diverse scales, including indoor, backyard, and commercial operations. Professionally, though, I work at Anthroponics, the inventors of the moving bed biofilm reactor. This is a type of biofilm technology for water and wastewater treatment. It's a very compact way to create your nitrates for aquaponics, for example. In fact, I think we have about 50 references worldwide in aquaculture, in the aquaculture industry, although this is mostly for the full nitrogen removal with denitrification. I particularly have been involved in many projects at my workplace: more efficient nitrogen removal in municipal wastewater, anaerobic MBBR with biogas production, net energy positive wastewater treatment. This means that a treatment plant creates more energy than it spends after treating the wastewater that's coming in, which is pretty cool. Biological removal of difficult compounds such as high salinity, selenium, phenol, etc., just to name a few. And this year we actually released a brand new biofilm technology, a 6 years of R&D project that I was involved with. And we were leveraging almost 40 years of MBBR development to achieve that. But yeah, that's my professional background. But I am actually here representing Ponic Labs as its co-founder. And Ponic Labs is a joint effort by me and my friend Martin to teach about all types of hydroponics and to help develop cutting-edge organic and sustainable hydroponic processes and best practices. And how we want to do that is through education and research, and maybe being involved a little bit in commercial projects. And we are currently working on our website where we will feature free libraries, books, and courses and consulting. The idea actually started in 2019, where we created a Spanish aquaponics course precisely because in many Spanish-speaking areas, mineral fertilizer is very hard to come by or expensive. So aquaponics is a superior alternative in these areas. All right, but now let's go into the actual talk. So when we talk about sustainable hydroponics, I like to focus on the fertilizer source first and work from there. And this is more or less my holistic view of the whole area of how we grow food in general. We have soil cultivation and intensive agriculture. That's how most of us have been getting our food in the past few hundred years. And here the nutrient source or the fertilizer source comes mostly from the Haber-Bosch process, where we extract nitrogen from the atmosphere, and also we extract some other non-renewable minerals from the earth. Then we have the organic / ecological / biological agriculture, where permaculture is a part of. There we're looking at waste recycling. We're taking waste streams, organic waste streams from somewhere, composting them, for example, then converting that into soil, living soil, fertilizer, etc. Within hydroponics, I would make a distinction that we have two main camps. One is the mineral hydroponics, the one people usually think about when you talk about hydroponics, mineral or inorganic hydroponics, where I would subdivide further into active or passive. Active here meaning that we are applying, of course, energy to keep things running, and passive meaning we're not applying energy directly in the plant section. But similar to soil industry in the intensive agriculture, we are still relying on extracting non-renewable minerals from the earth. Now, within organic hydroponics, we have aquaponics, of course, where we still rely mostly on industrial fishing to create the fish feed. So in that sense, it's not as sustainable as it could be, but it is still pretty sustainable. Then we have bioponics, which is sort of an umbrella term to refer to a way like with permaculture or organic agriculture or biological agriculture. We're taking an organic waste stream and converting that, except we're not converting that to soil, we're converting that into an organic liquid fertilizer. And lastly, anthroponics, where we take human waste like type 1 or type 2, and we do the same as with aquaponics and bioponics. We convert that into a valuable liquid fertilizer. So we all know more or less how active mineral hydroponics work. Here you can see a window garden that I built almost 10 years ago. And how it works in general is that you just purchase your liquid or your solid fertilizer. You mix it with the water to create your nutrient solution. And then you add to your system where you have water recirculation and aeration. And we know hydroponics is already fairly sustainable in terms of water usage, since the water is recirculated and reused as much as possible. However, we are relying on air pumps and water pumps to ensure optimum plant growth. So in that regards, passive mineral hydroponics is an advantage. It works the same as the other active mineral hydroponics, but there is no recirculation or active aeration. We prepare the full nutrient solution, and as the plant consumes it, the water level drops, and it develops air roots, which will help prevent the root rot. Most people know about this method as the Kratky method. However, all the first hydroponic experiments as far back as the 17th century were already all passive. So this is nothing new, so to speak. And here you can see some of my growth. I have made so much pesto from my basil at home, you would not believe. Also interesting in trying to make an already sustainable, so to speak, passive hydroponic system more is to reuse existing containers such as bottle waste. Here you can see I've used Tetra Pak packages, glass bottles, soda, plastic bottles. I've even built a shelf with old wine bottles and was able to do vertical passive mineral hydroponics. So you can really lower the carbon footprint this way. However, the problem persists that the mineral fertilizer we are using is still highly unsustainable. It's polluting, it's energy intensive, and it's extractive. So actually, my whole journey in hydroponics and aquaponics started with my thesis, my master thesis, almost exact to the date 10 years ago. I built a pilot system or actually 3 pilot systems with my coordinator in rural Sweden. And the first of these was a media bed type, where the plants are grown in a mix of clay pebbles and lava gravel. And then we also built in a greenhouse a nutrient film technique system with a deep water culture as well. The nutrient film technique is on the left and the deep water culture is on the right, and we have a separate biofilter above. I have also done a lot of small-scale indoor systems, as you can see here. However, when you do that, you lose the ability to grow edible fish, especially inside an apartment, because you're confined to the smaller ornamental fish that can fit in smaller tank sizes. However, the point stands. It's still possible to grow many plants without a typical mineral fertilizer, as with conventional hydroponics. You just need to feed the fish, and then the fish will produce the waste, and that is processed by the beneficial nitrifying bacteria, and then that is able to be safely absorbed by the plants. So no surprises there for all of you. Let me know if you guys have any issues. I see someone's sound is not working. Is anybody else hearing me? Okay. As I continued working a lot in aquaponics, I joined a lot of international events, mostly in Europe. The first one was in Warsaw, Poland, where this was mostly a soil-based event, but we were focusing a lot on community-supported agriculture, or CSA. Then I attended an event in Las Palmas in Spain, where we learned about fish diet and challenges with aquaculture and aquaponics. And lastly, I went to an event in Reykjavik, Iceland, where we learned about commercial opportunities and challenges with aquaponics. These last 2 aquaponic-focused events were part of the COST program and the EU Aquaponics Hub. So around this same year, 2015, 1 year after my master thesis, I helped create Sweden's first CSA vertical indoor aquaponics system prototype in an NGO in Malmö in the south of Sweden. And as you can see here, this is an indoor office space, so it's not a greenhouse, it's in the middle of the city in a previous office space, and it's a very compact plant area because we are using these towers, but we were able to grow year-round, even in the cold, snowy winters. So you can see here me on the right performing some water quality analysis, and on the left my friend Martin that I mentioned earlier doing some leaf inspection. And we are using the Bright Agrotech zip grow towers, if you've ever heard of them. These came from America, and the tanks that we used for the fish, they came from China. These towers have the biofilter media inside of them, so we did not have a separate biofilter media as is common in aquaponics. We had them in the towers themselves where the plants were, which had some advantages and disadvantages. But it was a very, very productive system. We grew lettuce, chard, pak choi, basil, oregano, sage, parsley, coriander, cabbage, spinach, chives, etc., etc. Very productive, more sustainable than hydroponics, but still we required more energy use in this daily operation. And we did have some issues with the leaking water from the Bright Agrotech towers, but nothing we couldn't solve in the end of the day. So in the context of sustainable hydroponics, the problem now is that the fish feed is originating in the oceans for the most part, which makes the system extractive. I know there are advances in land-based fish feed or using waste from other processes. Black soldier fly larva, for example, is often mentioned, but that has still not been able to replace traditional fish feed fully at a commercial scale. And if you're more interested in this commercial system that I helped operate and design, I have an hour-long video on my YouTube channel about it. Designing, construction, operation, lessons learned, etc. So, as you may have noticed previously from my thesis, I did not only work with aquaponics, I worked with urine and aquaponics, something that we can call Anthroponics, meaning deriving from man. Commonly, people refer to it as Bioponics. And here it's the same design principles as aquaponics, but we are skipping the fish and we're focusing solely on the bacteria and the plants. And we use urine because urine is easier to handle and easier to sterilize for this application. And this looks like a very complicated system, but it's just a prototype that I did for my thesis. We have the grow towers with some media, light expanded clay aggregate pebbles. And we have a raft on the left side, a deep water culture raft. And on the right, we have a media bed, again with the same lava gravel and clay pebbles. And we have a sump at the bottom. And there's a pump recirculating water to the top of the towers, a pump recirculating to the media bed, and within the media bed we had an extra pump because we had issues with the siphon, as many aquaponics people will have experienced. But yeah, we combined many different things, and the beautiful thing about this is that it was all powered by processed human urine. So after I finished my thesis, I decided to see how much can we really push the power of urine forward. I did many experiments, and these were all self-published as technical reports. So where we took these three type media bed systems and we did experiments. For example, this first one with lettuce. It was a very exciting system because that amount of lettuce you see there, that's about 3 full shopping bags of lettuce. That was grown from about this much urine. So we were able to prove experimentally that urine is a very potent fertilizer, at least for low nutrient crops like lettuce. And we calculated that on average, an adult human produces around 1.4 liters or almost 0.4 gallons of urine in just one day. And it is estimated that one human adult could produce almost 3 kilos or almost 7 pounds of lettuce from the urine they excrete in just one day. So every time you flush your toilet, you can think about that. You're throwing away a lot of valuable nutrients. Did some more experiments with Anthroponics. This time we tried to decouple the system. We have an MBBR with anox calnus K1 carriers. We have the urine, and once a week that water, after being nitrified, is then moved into the deep water culture component, and we were able to grow basil and coriander in this system. I did some more experiments with NFT systems. Here on the bottom left, you can see I built a homemade MBBR, and I'm using the Anox Calnus K5 media here. And the interesting thing about this system is that we designed it with an airlift system in mind. So we have an air pump pumping air into that. That air is strong enough to move the anox columnist media around, and at the same time, through the airlift system over there that you can kind of see the two pipes, part of the water is already being moved to the top of the NFT line, where it then passes through the bottom of the roots of the plants. So we were able to just use one pump to do the nitrification, to add the aeration, and to move the water for the plants. So still on the topic of organic hydroponics, there's the field also of bioponics. Bioponics is an umbrella term to refer to organic hydroponics. Most people know bioponics when you go to your normal hydroponic store and you buy, instead of the mineral fertilizer, you buy the organic liquid fertilizer. You just add it to your regular hydroponic system and it works. But the fun, I think, is making your own liquid fertilizer. So here, one of the first experiments we did, again, it's a media bed type system. And we had a vermicompost on this NGO where we added food waste. And the vermicompost is basically worms eating the food waste, creating soil. But part of that, in part of that process, there is a liquid left over that we call a vermicompost leachate. And that is what we used to supply to the system, only that. And we were able to grow this lettuce without any issue. Another experiment we did in 2019 was to use something called green waste biogas slurry. So in Sweden, in the parks, in the city parks, when they cut the grass, they send that to the treatment plant and they create biogas from that. But there is a leftover, a slurry leftover. Slurry meaning a mixture of solid and liquid. And we used that in an NFT style system. Again, we built a little MBBR. We added the Anox columnist K5 media. We used the zip grow towers here, so these were not the most optimal for NFTs. We had some issues with leaks, but overall we were able to grow a lot. So again, we proved that there's many different nutrient sources that you can get, and with the right system design, you can convert that into plant available nutrients. Another, still going back to the vermicompost, it occurred to me to have this experiment where, what if we take that soil that the worms produce and we dry it and we crush it to a fine powder and we add that to a hydroponic system. The theory here being that the vermicompost already has all the plant available nutrients in general, and they should not be affected by the drying and the crushing process. So if that is true, then that also means that there's no need for aeration, because as long as the powder is well mixed in the water. So on the first experiment on the left, we indeed were able to grow the basil when we had a little air pump just to mix everything around. And on the right, on my apartment, I grew some radishes. One of the systems I was providing oxygen supply, and then the others I was not, but both were able to produce radishes. So this for me opened a lot of exciting ideas, because if we don't need so much energy to move or to create an environment for bacteria, if we can get around this, maybe we can be even more sustainable. And as I have also worked a lot with Anthroponics, going back a little bit, as you know, I've experimented with the lettuce. We did some experiments with cucumbers, and we always noticed just from the urine that we had some nutrient deficiencies in the leaves, which made us think that perhaps we need to come up with some sort of recipe, something that still uses the processed urine as the main nitrogen source and other nutrients, but we then supplement with other things in some sort of bioreactor. Could be a biofilter, an MBBR, whatever. So for example, here, I theorized that this recipe could have the aged urine, the vermicompost leachate that I've already used, bokashi leachate. Bokashi is another quick composting way to process food waste. Wood ash to supplement, for example, some potassium, magnesium, and calcium. And because it's very important to have the right pH in hydroponics, we need to have some way to balance the pH after we've added all this stuff. And that I would use phosphoric acid or lime, calcium over there to regulate the pH, so it will be more optimum for the plants. So I got to work. I made this recipe, And then I tried growing this in passive systems. So on the left, you have a pot that has a mix of cocoa and perlite. And on the right, you have, again, the same cocoa perlite. But the key here is that we're adding the mixed recipe on the bottom, and then it's through a wicking effect going up to the roots of the plants. And I think that is an important part in supplying these sort of organic systems, because we've already used the energy to process this by moving the water and adding oxygen when we're making the recipe. Why? I don't think there is a need to add the oxygen in this last part. And indeed, it worked, as you can see. I was able to grow basil and make some pesto out of that. And I still kept thinking, what if I didn't have to even use energy, pumps, whatever, in the first place to process that organic waste? So I'm excited to announce that I think I've been able to crack that, and I'm calling it the MUNCH method, a method of upcycled, non-circulating hydroponics. Basically, it's a passive and an organic hydroponics method. So I took plant waste such as leaves, roots, stems, and old fruit, and I anaerobically fermented it for months. So this process occurred over a period of months, and it's a smelly process, but I did not use any energy, any electricity in mixing it or in aerating it in any way. And then the resulting liquid, I diluted and added it in a special way in this system here. The same one you recognize from the previous image is the same cocoa perlite mix, adding the liquid from the bottom. Behind it's regular beach sand from a nearby beach. And I have proven that it's been able to grow the plants just fine. I think, of course, this needs much more replication. I am hoping to write a technical report and to make some videos about it. So if you're interested in hearing more about this, I will share the updates on the Ponic Labs website as well as my ResearchGate page. And that is more or less the end of the presentation. I would also like to mention that we are considering making a very detailed course on sustainable hydroponics, including system designs, dimensioning, calculations, whatever. But that will be something later in the year or next year. But if you're interested, make sure you connect with me or follow our updates. And if you just want to reach out, either professionally because of Ano's calmness and our media, feel free to reach out, or other hydroponic collaborations, also feel free to reach out through Ponic Labs. So now I am opening for questions. I know there's already at least one or two here. Let's see. Did you compare the urine experiment to a control with no nutrients? No, I have not. I mean, or rather, I did not do it in a way that then I would write about it in the technical report. We did do some experiments where we have the regular hydroponic fertilizer, just plain water, and the aged processed urine. And of course, we could see that with no nutrients, the plants don't really grow at all. So there was not really any point on keep adding that control every time we were doing the tests. Josh says the urine is cool, but I wonder what consumer acceptance would be. That is part of the reason why I have moved a little bit less in experimenting with urine. Even though we have proven it that we can grow plants safely with urine. And if you're interested in reading more about the process, it's in the technical reports. But basically, we wait for the urea in the urine to be naturally converted to ammonia, and that can take between 2 and 6 months, or through a method that I write in one of the reports, you can make it almost instantly. But that process increases the pH of the solution to 9, where no bacteria or virus can survive for a long time. So that is a very safe, we make it very safe in that sense, but there's always that ick factor, right? There's that disgusting thing when we think about using our own waste to produce plants. So yeah, it is definitely difficult to push this forward, and not even to mention that combined wastewater is even more difficult. I've never had the resources in terms of lab equipment to even begin to to think about how we could use combined wastewater in that sense. But I have theorized, for example, that you could take type 2 human waste, and we know that black soldier fly larvae eat that. It's been documented in academia. What is not clear for me, though, is after they've eaten that, any diseases or any difficult compounds like pharmaceuticals, does that bioaccumulate then and go to the fish? Is there a way we can treat that so it does not go to fish? But there could be a way to incorporate that with aquaponics as well. Jim says, I'd be interested in knowing how the human diet and fluid intake habits impact the quality of urine. I am sure they intake it. I've never had the resources to make a comprehensive test, but for example, I have a vegetarian diet, so I'm sure that has influenced the type of nutrients that have been available in the urine that I used to the plants. But again, it would be difficult unless I was in a university with a very well-funded investigation process to be able to sample enough urine, and it would be difficult because not many cities do urine source separation. Most people just do their type 1 or their type 2 in the toilet, and that flow is combined and then reaches the municipal wastewater. So there's not many places that have a lot of urine that you can collect unless you do a massive campaign, and that would be also costly in terms of energy, labor, time, etc., money. But yeah, thank you all for seeing my presentation. Feel free to reach out, ask any more questions. I know there was a lot of information. There's a lot of technical details in the reports that I did not go into. They're all free to read, so let me know if you have trouble accessing any of them. Feel free to check out my YouTube website as well. I have many videos where you can see the plants and a little bit more detail of how things were built or how they were operating. I put other random videos there as well, but most of my videos still are related to hydroponics.